On Friday, what were we doing on Friday? Slope intercept. We were graphing, right? So what is the equation for slope intercept? What shape did this graph make? A line. What was the B called? Y-intercept, and then M is your slope. So we were still graphing. We are still going to be graphing, but all we're doing is we're going to graph and then kind of throw in that domain stuff that we were doing beforehand and kind of put the two together. You do not need to copy down this first picture, but this is the kind of stuff we're going to be doing. If you just look at this, what does it just look like? A bunch of lines, right? They're everywhere, but it's just a whole bunch of lines. Are they still straight lines, like linear pieces?
Yes.
Is it a whole line, though?
No.
Or is it just a piece of it? It's a piece of it. So what we're going to be graphing is just pieces of linear functions. So what, if you are going to title this page, what we're looking at today is piecewise functions. And what piecewise functions are is they're just pieces of functions. Notice how some of these have arrows, some of these have the circles. An open circle, do you remember what the open circle means? Not equal to, and then the closed-in circle is equal to. So we're just looking at pieces of functions that are all graphed together. For today, you need a pencil and you need an eraser. If you don't have either of those, there's erasers in the back cupboard, there's pencils with erasers back there. But since we're going to be just graphing pieces of these, we have to be able to erase. Before we start graphing, the one thing we just have to be clear about, and this is really the only confusing part of this because you guys know how to graph, is we're having domain restrictions, and what variable is the domain? Your x's. So somewhere you should draw this little picture. We're just going to draw an xy axis. And we're going to be looking at where domains get restricted, where they're larger or smaller. So if we're looking at just the domain, which way does your x-axis run? Left and right. So where would your x's get larger? Which direction?
Right.
To the right. So larger x's go right. That's a weird arrow. Where do smaller x's go? I didn't make it any better. So where are smaller x's? Left. Don't add this to your picture, but just like check it out. Between these 2 points, the purple one and the red one, which one has a smaller x value? The red one. So does this whole like x's, does it have anything to do with if it's up and down? No, and that's kind of the confusing part. So we're not looking up and down when we do these. We're doing domain, so x's, we're going side to side. First graph we're going to look at. Piecewise functions, they're written kind of strangely. You'll know you have a piecewise function because of that big curly bracket. So next to your first graph, copy down this equation. You can tell also it's a piecewise function right away because the lines are the pieces. So this piecewise function is going to have 2 pieces to it because there's 2 lines. The 2x minus 1 and the negative x, that looks exactly what we were doing on Friday. So what's the new part of these? The if and the inequality. So these parts right here, those are your domain restrictions. So that's the new part, because that'll tell us what piece we want to keep. When you start graphing these, you start graphing them just like normal. So you go to the first piece. Where does this graph start at? -1. So you go down to -1. How do you count out that slope? Up to over 1. When you say over, is it left or right?
Right.
Right. And then this is a time when you will want to put lots of dots, and you'll see why in the end you want a super accurate graph. Connect it through. So you'll still start by just graphing your line, finding the y-intercept, finding the slope, but then you have to figure out what piece you want to keep. So So the inequality tells you what piece you want to keep. This part right here is telling you where it's getting cut off at. So that graph is getting cut off when x equals 1. So you go to where x equals 1, and then you go to your graph. So x equals 1, and I'm just going to put a circle around it. So you find where x equals that number, go to your graph, and then you have to figure out, is it going to be an open circle or a closed circle? Is it equal to or not equal to? Not equal to, so it is an open circle. And this is saying we want to keep all of the x's that are less than 1. So just think left and right. Where are all the x's less than 1 on the number line? Are they on the left side or the right side? The left side. So this is telling me I want to keep the left side of my graph. So if I want to keep the left side, do we need the right side? No. So then you just take your eraser and you erase away the other part of it. So you want all of the x's that are less than 1, so we want to keep that left side. That piece is now done. Go on to the second piece. Where is this one's y-intercept? 0. So we start at 0. How do we count out that slope? Up or down? Down 1, right 1. So a slope of -1. And then you want to figure out what piece do you keep. First look at it and figure out, okay, what number are we being cut off at? 1. So you go to where x is 1, and then go to your graph and put a circle there. Decide, does it get filled in or does it stay open? This one gets filled in because it's or equal to. And now we want to keep all the x's that are greater than 1. So where are all your x's that are greater than 1? On the left side or on the right side? Right side. So if we want the right side, what do we do to the left side? Erase it. So the confusing part of this is a lot of times when you see greater than, you're used to saying like it's the top half, but did we keep the top half there? No, so just make sure you always look left and right. Your final check is always, are your circles on top of each other? Yes. Do you have one open, one closed? Are your arrows pointing 2 different ways, like one to the left, one to the right? So if you have arrows, they have to be pointing different ways. If those 3 things check out, you either did it all right or you did everything backwards. The chances of you doing everything backwards are very little. So if those 3 check out, you're probably good. One more like this. And they should both be -4s for the inequalities. How many pieces is this graph going to have? 2. There's 2 lines. So however many lines there are, that's how many pieces you're going to have. Start by just graphing it normally. So that first equation, where is its y-intercept? -5. How will you count out its slope? Down 1, right 2, down 1, right 2. Figure out where it's getting cut off at. So what number is that one getting cut off at? -4. So you go to where x is -4 and then go down to your graph, put a circle. I like putting big circles just because then it's easy for me to tell, like, yeah, that's where it is. Is it open or closed? Closed. It's or equal to. And then figure out what side you want to keep. So we want all the x's that are less than -4. So where are the numbers less than that? To the left or to the right? to the left. So we want to keep the left side, which means, what do we do to this other side?
Erase it.
Erase it, get rid of it. You guys try the second piece. So, what number does it get cut off at? -4. So -4, go to your graph. Circle, should it be open or closed? Open, and we want all the x's that are greater than -4. So are the greater than on the right side or the left side? Right side. Final check, are the circles on top of each other? One open, one closed. We have arrows pointing in opposite ways. That's how you know you did it correctly. Those 3 things check out, you're good to go. Questions on this style? One thing I want to mention, because it pops up in your homework a couple times, if you have a line that's like this, and then another line that's like this, and they both intersect at the same part, you can have your circles on top of each other. Because they're still technically in a line, aren't they? They're just like right on top of each other. So that's okay. If that happens, I always show that by doing a filled in circle and then putting another circle around it just to show like, hey, I know they're both there. But in reality, if you have that, what it ends up looking like is just one big circle, because like the filled in one is gonna override the other one. But just know that that's okay for your circles to be on top of each other because they're still vertically aligned. The last style we have to go through just has a different look to it, and it's confusing just because we forget what equations mean. So last one we're going to do here. How many pieces is this one going to have? 3. What's different about these ones? Yeah, there's no slope. There's no x. When you have that, really what this is saying, and all of these, like each piece is really just saying like y equals whatever your equation is. Anybody remember what y equals are? Because this is saying like your y's always equal -2. So what kind of line would have y's that always equal -2? Horizontal lines. These are all just horizontal lines. If you have no x's, they will forever be horizontal lines because it's just saying y equals. Because if you think about it, when I put my first point down, a y-intercept of -2, if I go over to the side one, doesn't that y still equal -2? So if you just have no numbers, no x's, all it is a horizontal line. So you still graph them the same, you just have to kind of realize that if it's just a number, it's a horizontal line. Where is that one getting cut off at? 1. So you go to 1, go down to your line, put a circle there, decide should it be open or closed? Closed, it's or equal to. And then, do I want to keep the left side or the right side? Where are all my x's that are less than 1? On the left. So I want to keep the left side because that's where all my x's are less than 1, which means what happens to the right side? Erase, go away. So that's your first step. First part. Now go to your next piece. Where's our next horizontal line at? 4. This one ends up being kind of doubly weird because what kind of inequality is that right there? Is it a one-sided or a two-sided? Two-sided. Remember, two-sided just means this one just has one side because it has one dot. So a two-sided is going to have how many dots? Two of them. Where's the first one at? One. So you go to one, put a circle. Is it open or closed? Open. Where's the second one at? Three. Open or closed? Open. And then this is saying you want 1 to be less than x to be less than 3. So do we want to keep the inside or the outside? The inside. So whenever you have a two-sided inequality, it just means keep the inside, because this is saying it just wants all the x's between 1 and 3. So you keep the insides. Where's our last piece at? Up at 6. So if there's just an x, horizontal lines, so these ones are actually easier to graph as long as you recognize it. Where's this one getting cut off at? 3. Open or closed?
Closed.
Closed. And we want all the x's that are greater than 3 on the right side. What are you trying to figure out, Tori?
I got it.
Okay, so just graph the whole line and then just look at it, and it's a left or right, not an up or down. This function, this idea when you have horizontal lines in there, don't these kind of just look like a staircase? Like you would just walk up these steps? You'll see this referred to as a step function. So a step function just means it's the horizontal line. So if you have a graph of all horizontal lines, it's a step function. You'll sometimes just randomly see, like, given this step function, it just means horizontal lines. So questions on the piecewise functions. Before I give you guys your homework, I need to show you a couple of things. Classroom. I'm going to have you guys all sign up for Classroom right now. So either grab your phone, grab a Chromebook. The code is up there. You guys are period 3. Some of you did it before you